This presentation will provide an overview of the work that has been completed on the Lurline Bay, Matraville, Malabar and Yarra Bay flood study. It'll summarise how the study was completed and how the community can find out more about the study and provide feedback on the draft report that is currently on public exhibition. This map shows the extent of the study area for the project, and the study area actually comprises two separate areas. We have what we refer to as the northern area, which is the Lurline Bay catchment, and that incorporates parts of South Coogee and covers a total area of 0.7 square kilometres. This section down the bottom here, the southern section, comprises three separate catchments. The Matraville catchment, which is shown here in yellow, which drains down into Bunurong Creek, which in turn drains down towards Port Botany. We have the Yarra Bay catchment, which is shown here in magenta, and it drains down into an unnamed watercourse and down into Phillip Bay. And we also have the Malabar catchment, which is shown here in green, which drains in an easterly direction down into the Tasman Sea. And these three catchments collectively cover the suburbs of Matraville, Chifley, Malabar, Phillip Bay, Little Bay and La Perouse, and they cover a total area of 9 square kilometres. This project is being completed as part of the New South Wales Government's floodplain risk management process, which is designed to reduce the impact that flooding has on the community. And the floodplain risk management process is a multi-stage process. The flood study represents stage 2 in the process. And the key goal with the flood study is to quantify the nature and extent of existing flood behaviour. And by doing that, it enables us to identify where there are potential flooding problems, which we can then look to rectify during subsequent stages of the floodplain risk management process. The flood study comprises 5 stages of work. Stage 1 involved data collection and review, as well as consultation with the community. Stage 2 included the development and calibration of computer flood models. Stage 3 of the project took those flood models and used it to undertake design flood modelling as well as mapping. And Stage 4 of the project involved the preparation of a draft flood study report, which is where we're currently up to in the project. So over the next series of slides, I'll run you through the work that's been completed as part of the first 4 stages of work and outline how you can become involved in the project that will ultimately enable us to produce the final flood study report. The first part of stage 1 of the project involved collating and reviewing all available flood data. So that included past flooding reports, hydrologic data such as rainfall, topographic data such as survey and LiDAR, as well as GIS data and in particular stormwater information. And by undertaking a review of that information, we could understand where there were data gaps that would need to be filled in order to complete the study. And those data gaps were filled using information collected by council staff as well as surveyors. And that included the survey of creek cross sections to ensure the flow carrying capacity of those watercourses was defined, a survey of bridges and culverts, as well as picking up the details of stormwater pits and pipes scattered across the study area. The second part of stage 1 involved consultation with the community. And the goal of the community consultation was to inform the community about the study and also to get information about the community's past flooding experiences, which could then assist in the calibration of the computer flood models that we were to develop during stage 2 of the project. So the consultation was undertaken in early 2020 and included mailing out over 1,500 letters and questionnaires to residents and business owners in the study area. And overall, we received 421 questionnaire responses back, which is more than a 25% response rate. We analysed the questionnaire responses, and that determined that around 37% of the respondents had experienced some sort of flooding impacts. And the most common flood impact was flooding of roads, followed by inundation of roadways, so roads being cut by floodwaters. As part of the questionnaire responses, we also asked the community to provide information on historic floods, and that included provision of flood photographs, a couple of which are shown up on screen at the moment. And these photos are indicative of the types of flooding that people were reporting. in general, fairly shallow but fast-moving floodwater. Stage 2 of the project involved the development and calibration of computer flood models. And we developed two types of computer flood models for this project. The first model we developed is referred to as a hydrologic model, which is used to simulate the transformation of rainfall into runoff. So it will take rainfall estimates and use that to determine how much of that rainfall would actually infiltrate into the soils and how much of that runoff would be left to actually enter the stormwater system and watercourses. The second model we developed is referred to as a hydraulic model, and that takes the flow estimates from the hydrologic model and is used to simulate how that runoff would actually move and be distributed across the study area. And we can use the hydraulic computer model to generate estimates of flood depths, velocities, and levels. But before we could actually use those models to undertake any design simulations, we wanted to calibrate the models to make sure they were providing realistic flood estimates. And we calibrated the flood models by using information provided by the community as part of the questionnaire responses. And in general, we found that the hydraulic model was able to provide a good agreement between the flood depths reported by the community and the flood depths that were actually generated or simulated by the computer model. The average difference between reported depths and simulated flood depths from our computer model was just 3 centimetres. We then moved to stage 3 of the project, which involved taking those calibrated computer models and using it to simulate a range of design floods. And design floods are hypothetical floods based on their chance of occurring. So that ranged from very frequent floods, so floods that you would likely see on average once a year, right through to the biggest flood that could conceivably occur, which is referred to as the probable maximum flood. And we also used the results generated by the computer flood models to prepare a range of flood maps. And this included flood depth mapping, flood level mapping, velocity mapping, hazard category mapping, as well as flood emergency response classifications, which will assist the SES in emergency response planning. This is an example of one of the flood maps that have been generated as part of the project. In this case, we are showing peak floodwater depths for the 1% annual exceedance probability flood. So this is a flood that has a 1% chance of occurring in any one year, so it's quite a rare event. And the different colours here correspond to different water depths. So lighter blues correspond to shallower water, and the darker blues and the maroon correspond to deeper water, in this case more than a metre depth of water. And we're focused in this case on an area around Chifley, and you can see for the most part water is contained in close proximity to defined watercourses, although we do see some ponding along local roads, and we do see some water actually travelling through properties. Up here we've got Bunurong Road, and you can see there's quite extensive inundation in this area, although all of this area is currently open space. So we've prepared maps like this for each of the design floods that we've prepared, covering the complete study area. This is an example of another type of flood map that we produced as part of the project, and this is a flood hazard map again for the 1% AEP flood. And flood hazard mapping is prepared by taking the velocity and depth outputs from the computer modelling and using that to determine the likely impact that floodwaters will have on people, vehicles and buildings within the study area. So you can see we've broken down the inundated areas into one of 6 different hazard categories, ranging from H1, which is generally safe for people, H3, which is unsafe for vehicles, children and elderly, right through to H6, where there's potential for structural damage to buildings. And you can see across most areas, we're looking at dark blue and light blue, which is either generally safe or unsafe for small vehicles. Areas where we've got H3, for example, here would be unsafe for children, and they generally correspond to open space, parks and detention basins, which are designed for water. However, we do have this area of Anzac Parade, for example, which would be unsafe for children and elderly. And we do have little pockets of H4, which would also be unsafe for adults. So again, mapping like this has been produced for a range of different flood sizes so we can get an understanding of the impact that flooding will have to vehicles, people and buildings across a full range of floods. In addition to undertaking an assessment of existing flooding, we also quantified the potential future flood risks. So we looked at what impacts future catchment development would have. So that included assessing the impact that increased runoff rates and volumes associated with additional development might have on the existing flood risk, as well as what impact of filling of different parts of the floodplain might have on flood behaviour. And we also completed a climate change assessment which looked at the impacts of increased rainfall as well as the impacts of sea level rise. We then moved on to stage 4, which involved the preparation of a draft flood study report. And the flood study report documents all stages of the project, so it documents how the flood models were developed as well as key study findings. And the flood study report comprises 2 separate volumes, an A4 volume, which is shown there on the left, and that contains the report text and appendices, and an A3 volume, which is shown on the right there, that contains all the flood mapping that's been produced as part of the project. Mentioned earlier, the draft flood study report is now on public exhibition, and it will remain on public exhibition until the 17th of September 2021. And you can view the draft report online via Council's Your Say website, which is shown there on screen at the moment. In addition, we'll be hosting online meetings on the 25th, 26th and 27th of August, and you can make bookings for those meetings using that same Your Say website. And the online meetings will provide an opportunity for you to speak one-on-one with the consultants responsible for preparing the flood study, as well as Council staff, ask questions and raise any concerns that you might have. If you do have any comments on the draft report, please submit those comments in writing via the Your Say website, but please note that submissions close at 5 p.m. on the 17th of September 2021. All submissions that are received will be reviewed, assessed and addressed as part of the final flood study report. That concludes this presentation. If you do have any questions, feel free to submit those on the Your Say website or feel free to attend one of the online meetings. Thank you.